Okay, so trying to finish up with horizontal asymptotes or end behavior. So we were talking about comparing the degree of the numerator with the degree of the denominator, okay? And when you're comparing the size of two things, they can either be the same size, and we're talking about the degree of this numerator and the degree of the denominator. They're both x squares. So that means they're the same size. That means the exponents are the same. So the way you find the horizontal asymptote or the end behavior is you divide the coefficients. Okay, so the coefficient on the leading term and the coefficient on the leading term is where your horizontal asymptote is going to be. So this is a horizontal asymptote at y equals 2/3. Okay, the other thing you could have is in the numerator, you could have an x squared term. In the denominator, you would have just an x term. That's one possibility. So it's bigger on top. So if it's bigger on top, then we're dealing with bottom, okay? And bottom means there's not a horizontal asymptote. Now, this means that you have some other kind of asymptote, like maybe a slant asymptote, or it's called, you have a slant asymptote, or you have, it's also called an oblique, oblique asymptote. But bottom line is, if you don't have a horizontal asymptote, that's all you need to tell me. There's not one, okay? In pre-cal or in college algebra, you will probably have to find these slant asymptotes, and you would do it by long division, okay? So you technically do know how to do this, but I don't think that Algebra 2 is required to find those slant or oblique asymptotes. Okay, so the only other thing it could be, okay, we've talked about, we've said, okay, the numerator and the denominator, the degree of the polynomial could be the same, or you could be bigger on top, or what's the third outcome? You could have a function that has, let's say, an x squared plus blah, blah, blah over an x cubed plus blah, 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 because I really don't care about everything else. Okay, you compare the size of the degrees of the polynomial. A second degree polynomial is on top, a third degree polynomial is on bottom. Where is it bigger? It's bigger on bottom. That's BOBO. And what that means is you're going to have a horizontal asymptote at y equals 0. That's what that last O stands for. Bigger on bottom means you're going to have an asymptote at y equals 0. Okay, so your x-axis is going to be the horizontal asymptote. Okay, so it's going to be doing something like this, maybe. Okay, and whatever it's doing in the middle. But it's going to be approaching that at the ends. Okay, so that's what BOBO bottom means. All right, I'm just going to review real quick. I'll probably, well, no, I think I got time. I'm going to do one more example. Let me go to this thing right here. I'm going to copy this and go over here and paste it. And then that way, when we do an example right here, we will get a place to graph it. Okay, so let me see if I can find an example. Okay, so we're going to do oh shoot. Let's do another one out of the book. They're saying f of x equals x squared plus 5x minus 14, and that's over, oh, guess what? X squared minus 4. Boy, they sure do like that one. Okay, step 1, factor. Okay, step 1 is to factor. All right, so f of x becomes x plus 7 and x minus 2. The denominator is x plus 2, x minus 2. Okay, so step 2 is to find wholes. Okay, so how do we find the wholes? We take what's canceled out, x minus 2, set it equal to 0. So we have a whole at 2 comma what? I don't know until I take that and I plug it in to what's left. Let me change that to an x. Okay, the simplified version of my problem is this. So now I'm going to plug in 2 plus 7 over 2 plus 2. That equals 9 over 4. So my whole is at 2 comma 9 over 4. 9 over 4 is, what's the decimal value of 9 over 4? I need that. 9 over 4 is 2.25. So it's going to be 2 and 2.25. Okay, so when I go over here, I know at 2 and 2.25, which is right there, I have a whole. Okay, so that's what I know about my graph so far. Step 3 was to find the other point of discontinuity. That's removable discontinuity. Find your vertical asymptote. Vertical asymptote is non-removable. What do? We set the denominator equal to 0. X plus 2 equals 0. X equals negative 2 is my vertical asymptote. Okay, vertical asymptote at x equals negative 2. So over here at x equals negative 2, I'm going to draw my vertical asymptote. Okay, next thing to find is my zeros. And I find zeros. Step 4 is to find my zeros, or my x-intercepts. How do I do that? I take my numerator and set it equal to 0. So my numerator is x plus 7. Set that equal to 0. That means x equals negative 7. So at negative 7 is going to be where? Oh, pooh, I don't have it. X equals negative 7. That's 5. That's 6. That's probably negative 7. That's where my thing's going to be crossing the x-axis. Okay. Step number 5. Step 5 is to find my y-intercepts. Find y-intercepts. And how do I find my y-intercepts? I plug in 0. So I have 0 plus 7 over 0 plus 2. So 7 over 2. Y 7 over 2 is my y-intercept. 7 divided by 2 is about 3.5. Okay, so my y-intercept is at 0, 3.5, 0, 3.5. So there's my y-intercept right there. And I'm running out of time. I think I'm going to have enough time. Step 6 is my end behavior. Step 6, exponents are the same. So it's eats DC. The coefficients are both 1. So it's y equals 1. I'll finish this on the next video.